Welcome back to the Deep Dive. Today we're getting into something really important in software development, though maybe a bit under the radar, sometimes thread testing.
That's right.
If you've ever wondered how complex apps, manage to juggle multiple things smoothly without freezing or crashing on you, well, this is going to be really insightful.
Absolutely. So at its core, thread testing is basically a specific kind of software check.
Okay.
It focuses on making sure the key functions of a specific task or thread are working correctly within the larger application.
The thread.
Yeah. And it usually happens quite early on during what we call the integration testing phase. You could almost call it thread interaction testing, really.
Interaction testing, right, because it's about how they work together.
Exactly. It's less about the thread in isolation and more about how it interacts with others.
Okay. So our goal today isn't just to define it, but really understand why it's so critical for making software reliable. How it stops those annoying glitches.
Precisely. Think of it like this. Maybe an app is a busy factory.
Okay, I like analogies.
Each thread is like the tiny separate assembly line doing its specific job.
Right.
Sometimes these lines need to share tools or parts. Thread testing helps make sure they don't, get in each other's way or break the shared tools.
Ah, okay, that makes sense. So these workers, these threads, are there different kinds we test?
We generally break it down into two main types. There's single thread testing.
Mm-hmm.
That's where you're just looking at one specific transaction, one assembly line, basically.
Simple enough.
And then there's multi-thread testing. That's when you have several assembly lines, several transactions running all at the same time concurrently.
And I'm guessing that's where the complexity really ramps up.
Oh, definitely. That's where things get profoundly complex, but also really interesting.
So thread testing isn't about checking components one by one then. What's the core idea, especially with multi-threading?
Yeah, fundamentally, it's not about the individual pieces in isolation. It's all about how different functional paths, different sequences of operations interact.
Interact, like bumping into each other, going back to the factory.
Exactly like that. It's where the different moving parts of the software actually meet and have to coordinate. It helps developers see the bigger picture, focusing on these logical execution paths across the whole system.
Logical execution paths.
Yeah.
Like the journey a feature takes from a click to the result, potentially crossing paths with other threads doing their own thing.
That's a great way to put it, especially when multiple threads are active.
Right. Now, you mentioned multi-thread testing is complex. I hear the biggest headache is actually creating tests that can reliably reproduce the bugs. These things are like ghosts sometimes.
They really are. Reproducible unit tests for multi-threaded scenarios are incredibly difficult to program.
Why is that?
Well, the criteria are just different from single-thread tests. You've got factors like available memory, storage speed, and critically tiny timing differences that depend heavily on the specific hardware being used.
So it's not just speed, but the order things happen in.
Exactly. The unpredictable order in which threads access shared data can lead to these really elusive bugs, things like race conditions or deadlocks. They don't always show up the same way twice, which makes them a nightmare to pin down.
So how do developers hunt these down if you can't easily write a test for it?
Well, it takes a combination of approaches. Very careful, meticulous code inspection is one part.
Okay.
And then running the program over and over again, but with different mixes of applications or features running concurrently, trying different stress levels, multiple instances, basically trying to force that rare problematic interaction to happen.
Almost like setting a trap for the ghost bug.
Sort of, yeah. You're trying to create the specific, often rare conditions under which the bug appears.
So let's bring this back to the listener. What does all this complex testing mean for you when you're just, using your phone or computer? It means that next time you're multitasking, maybe switching between apps or using an app that's doing multiple things at once and it all just works smoothly without crashing or freezing. You can appreciate that intricate thread interaction testing was likely a big part of making it reliable. It's not just that individual parts work, but the whole orchestra plays together perfectly.
Well said. And it raises a really interesting thought for the future, too.
Oh.
Well, given how software keeps getting more complex and we all demand seamless multitasking, how might new tools, maybe AI-driven testing tools, change how we tackle these really tricky, hard-to-reproduce, multi-thread bugs?
Ah, that's a fascinating question. Could AI help predict or force those rare conditions?
Potentially. It's definitely something for you to mull over as you navigate our increasingly complex digital world. How do we ensure reliability when everything is happening at once?